Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
All right, good morning, everyone. First of all, I would like to announce that yesterday I've received the examination date for your mid-semester test. Because we have very large size enrolled in this unit, so in order to accommodate 550 plus students, the school is only able to find 3 venues on 29th of March. All right, so the mid-semester test will be taking place in the evening of 29th of March. All right, so which is next week and next week. Okay, so well, if you like, that's kind of like the bad news for you guys, because in the uni outline, I written the mid-semester test is on the 1st of April. So all you lost is actually the weekend. All right, so nothing to lose. Now, in order to make up for that, I said in the uni outline, I said that the examinable materials from week 1 to week 4, right? So the week 4 is all about options. Now the good news is, because the exam was advanced 2 days, so the option trading strategy will not be examined in the mid-semester test, okay? So don't panic if you see a lot of like the option trading strategy. Of course, we're gonna go through all of that, but that will not be examined in the mid-semester test, okay? Is that clear? So next week, I'll give you guys an exact time, when, and the location for the mid-semester test. But from what I received so far is that the mid-semester test will be taking place on the 29th of March. Does that make sense? Okay, so that's the first thing I would like to talk about. And, oh yes, the next thing is that, so next week you still have a quiz. So the quiz on valuing the interest rate swap, okay? So any other questions before we start? Yes? Sorry, can you repeat your question? No. Week 4 material is option, right? So the option material is covered. So it will be examined. But the option trading strategy part of week 4 will not be examined, all right? Okay, so in week 4 you have a lot of stuff, you know, but the second part, which I'll talk about, option trading strategy, that part will not be examined. And also, I just updated lecture slides for lecture 4. So don't download this one. I'll make a new updates tonight. So, but don't panic. The option trading strategy will not be examined. But the option parts will still be examined, okay? Yes, you're right. From the first week all the way until week 4, that will be examined. Any other questions? Any other question before we proceed? All right, if not, so let's start our real business. So yesterday, I went through designing an interest rate swap, which would converting liabilities from floating rate to fixed, from fixed to the floating, Today, we're going to do exactly that, but with investments, all right? So let's read the questions. The companies X and Y have been offered following rate per annum on a 10 million 10-year investment, all right? So what we can see is that company X investment project can either provide company X 5% fixed rate of return. Remember, this is rate of return, is not interest payment, okay? So yesterday what we have done is interest expense, but today this is rate of return. Now, alternatively, company X can invest in a project that would provide company X a floating rate of return, which is the LIBOR rate. So these two represent the highest possible rate of return that company X is able to get. Does it make sense? Now, similarly with company Y, so company Y is able to invest in the project which would yield a fixed rate of return 8.2% per annum. Alternatively, company Y can invest in a project which would provide Y LIBOR plus 1 floating rate of return. Right? So those are the highest possible rate of return that company Y is able to get. Now the question says, company X, what company X really wants is X wants a fixed rate investment, okay? And what Y wants is a floating rate investment. And the question says, please design a swap which would enable bank who acting as intermediary earn 20 basis points commission. And this time, we're not going to design this swap, two parties share the game equally, but in this case, company Y will receive 75% of the game. Right? So when you design the swap, when you're sharing the game between two parties, bear in mind, this time, Y is going to take the lion's share. Does that make sense? All right, so just bear that in mind. And first of all, usual stuff. Let's analyze what kind of comparative advantage the two party has got. All right. Right, so same old table here. If we work out the difference in the fixed rate of return, we see that Y dominates, right? So Y in fixed investment project can yield 3.2% higher return compared to Y's project. Yes? And also, in the floating rate of return, Y still dominates, because Y's floating rate of return is 1% higher than company X floating rate of return. So in other words, Y has this absolute advantage over X. But we see the gap is smaller in the floating rate of return than that of the fixed rate of return. Yes? So if the gap is smaller in the floating rate of return, which means the company X has a comparative advantage in the floating rate kind of investment opportunity here. Whereas company Y has a comparative advantage in the fixed rate of return investment opportunity. Does that make sense? Yes? All right, if that's the case, then we'll work out the difference in the difference, which is 3.2 minus 1%, so 2.2% gain. But one thing is that the swap bank is going to take 20 basis point cut, so we'll have to take out that 20 basis points. So we're left with 2% to play around with. Now, because company Y is going to receive 75% of the game, so how much better off company Y should be? 2% multiplied by 75% of the game, so that represents 1.5% of the game goes to company Y, and the remaining 50 basis points goes to company X. Right? So when we design the swap, we have to bear that in mind. So let's start the swap. So let's start with company X. So what company X really wants is a fixed rate of return. But we understand that the company X comparative advantage lies in floating rate investment opportunity here. Right? So what we're going to do as a swap bank, we're going to tell company X that, okay, I understand you want a fixed rate of return, but just, bear with us. Invest your $10 million into your floating rate investment opportunity. So company X did exactly that. So company X paid $10 million, and that investment yields the LIBOR rate of return to company X. And because company Y, what company Y really wants is company Y wants floating rate of return, right? So we say, okay, if that's the case, then company X can pay the floating rate of return directly to Y. So company X pay the bank LIBOR, then the bank don't take any cut. Bank simply passing the LIBOR to Y. Remember what I mentioned yesterday, when we're doing designing the swap, we keep the floating rate paid all the way across, and we're going to manipulate the fixed rate. Although there are alternative ways to do this, but this is kind of like a simple way, right? So you only need to manipulate one thing, which is the fixed rate. If you want to do alternative way, then you have to manipulate two rates, which is, take too much time in the exam situation. Anyway, so company X pay the LIBOR to the bank passing the LIBOR to Y, and we understand the company Y's comparative advantage lies in the fixed rate, right? So we're going to ask company Y to invest his $10 million in a fixed rate investment opportunity, which provide 8.2% return to Y. Now, because Y wants the floating rate, so Y get the floating rate from X. Now it's the time for Y to pay the fixed rate to X, right? So that's part of the deal. Now it begs the question, how much to pay? How much to pay to the swap bank, and how much swap bank should passing on to Y? So the question of how much is that we have a target here. The Y should be better off 1.5%. Now let's have a look what Y got from his floating rate of deal. Now, Y by himself, he could have got LIBOR plus 1% just on its own, right? So Y can get the highest possible rate of return that Y can get on his own is LIBOR plus 1%. But at the moment, X is paying Y LIBOR, which means the company Y is worse off 1% from the floating rate deal. Yes? Because Y on his own can get LIBOR plus 1. I mean, X is only paying the LIBOR, so Y is worse off by 1% from the floating rate deal, which means in the fixed rate deal, Y has to be better off at least 2.5% in order to make up the overall gain of 1.5%. Does that make sense? Now, I wrote here, I said, Y lost 1% from the floating rate deal, so Y needs to be better off by 2.5% from the fixed rate deal in order to get an overall gain of 1.5. Which means, now the fixed rate that Y going to pay the swap bank is going to be 8.2 minus 2.5%. So Y pays the swap bank 5.7%. So Y pays the bank 5.7, then the bank take 20 basis point cuts and passing the remaining 5.5 to company X. Now, so let's analyze whether each party got what they want. So company X received the LIBOR and paid all the LIBOR all the way across. So the LIBOR and the LIBOR cancel each other out. And the highest possible fixed rate that Y could ever get is 5%, but instead X is receiving 5.5%. In that sense, X is better off by 0.5%, right? So we achieve our target. So 0.5% better off for company X. Now, what about company Y? So as I mentioned, the company Y lost 1% from the floating rate deal, but company Y better off by 2.5% because company Y is paying 5.7%, on the other hand, receiving 8.2%. So company Y is better off 2.5 from the fixed rate deal, worse off 1% from the floating rate deal. Overall gain for Y is 1.5. Again, the box is ticked, right? So we achieved the target for company Y. So the logic for designing the swap for the investment vehicle is exactly the same for the interest rate swap on the loan, on the liability, right? But this time, we're going to seek the highest possible rate instead of the lowest possible cost of borrowing. Does it make sense? Any questions in this interest rate swap? Okay, so this table here details the logic which I just illustrated. So company X, if you work that table through, you realize company X is better off 50 basis points, and company Y is better off by 1.5%. Yes, so if what I just mentioned is, if I talk too fast, you can work through this table by yourself, and you will realize we achieve our target. Any questions before we move on? All right, so valuing interest rate swap. As I mentioned yesterday, when the interest rate swap was just entered, it has initial value of 0. Now, because one party is paying the floating rate, and the other party is receiving the floating rate, paying out the fixed, and the floating rate changes over time, so the benefit would accrue to one party and at the cost of the other party. All right, it's really depends on which position you're in. So the way we're going to value the interest rate swap is we're going to value them as two bonds, one fixed rate bond and one floating rate bond. So yesterday I was talking about taking a long position in the fixed rate, taking a short position in the floating rate. That is too confusing. I think the simplest way just to think about this intuitively. Now, if you are paying out floating rate, if you are a floating rate payer, then if the floating rate value is larger than the fixed rate value, which means you are paying more than what you receive, right? Of course, you get a negative value. So that's why there's a negative sign in front of this floating rate bond. Does it make sense? Now, similarly, with the fixed rate payer, if you're paying out the fixed rate bond, if the value of the fixed rate bond is larger than the value of floating rate bond, which means you are paying out more than what you receive, right? So that's why there's a minus sign in front of that. Does it make sense? So you can think about what you're paying, what you're receiving. Is what you're paying larger than what you're receiving, or is what you're receiving is larger than what you're paying, instead of thinking about taking long or short position. I think long or short position confuse a lot of people. Okay? So if we have that mindset, so let's work this through. Now, we know how to value the fixed rate bond. We simply discount all the cash flow back to the present. We know how to do that. We know how to find the coupon rate. And all we need to do is we need to use the maturity of the discounting rate matches with the time horizon of the cash flow. Okay? So that's the only thing you have to be aware of when it comes to valuing the fixed rate bond. Now, valuing the floating rate is even easier, but the concept is kind of confusing. So why is confusing? Okay, so I'll talk this through again. Because we're valuing the swap in the middle of the swap. So which means there will be a previous payment paid, right? So there will be a previous payment exchanged. Floating payment exchange with fixed payment somewhere here, which has already gone, all right? And in that previous payment date, they have to do another thing, which is to determine the floating rate payment for the next payment date, which means they will determine this K star. You guys see the K star? The K star is the floating rate payment. They would determine the K star at the previous payment date somewhere here, which has already gone, all right? And the K star will be paid in the future, which is, in T star time. So the K star will be paid in T star time, right? So after the K star is paid, the floating rate bond is worth principal, is worth at notional principal. Why? Because after this K star is paid, all of the coupon rate would equal to the floating rate, which is your discounting rate. So you have a situation which your coupon rate is identical to your discounting rate, so this bond is fairly priced, right? So this is a bond price at the par value. So that's why the bond is worth L immediately after the payment of K. Well, if that's the case, all we need to do to value the floating rate bond is to discounting the L plus K star back to the present. That's the only thing you have to worry about with the floating rate bond. Does it make sense? Does it make sense? Okay, so just bear that in mind. So let's read this question. It says, suppose the Macquarie Bank has agreed to pay 6 months BBSW rate. So the full name is Bank Bill Swap Rate. So the BBSW rate is kind of Australian version of the LIBOR rate. All right? So BBSW rate is just a floating rate. Agreed to pay 6 months BBSW rate, receive 8% per annum with semi-annual compounding on the notional principal of 100 million. And swap was entered some time ago, and the swap has 1.25 years life remaining, and the BBSW rate continuously compounded for 3, 9, 15 months is this much, all right? And the last piece of information mentioned that 6 months BBSW rate at the last payment date was 4.5%. So what does this mean? That means the BBSW rate in the previous payment date is 4.5%, and that determines your K-star. And the K-star has not been paid yet. All right? So here I draw the timeline. So this could have been a 2-year swap. So this could have been a 2-year swap, but this time has passed. Now we're standing at this point. So yesterday I've used the same timeline to illustrate the value interest rate swap. A lot of people got confused. So they will ask me why I'm not discounting back to that point on the green line. So just ignore the first part. Just focus on the purple line, okay? The purple line is the present. So all of that is kind of already finished, already passed. It's gone. It's in the past. The reason why I draw this gray line is because I want you to have a benchmark to imagine this could have been a 2-year swap. All right? So the 6 months BBSW rate in the previous payment day, which is this point, was 4.5%. And that determines your next coupon will be paid in 3 months' time, in this point, right? So all we need to do is to work out the coupon, and we discount that coupon together with the notional principal back to this date to work out the value of the floating rate bond. So let's work on the floating rate bond first, okay? So as I mentioned earlier, so the 4.5% determines your next K-star, your next floating rate payment, and that multiplied by 100 million divided by 2, because that's paid semi-annually, divided by 2. And also, remember, you have to discount back your notional principal. And what kind of discounting rate are you going to use? You're going to use the 3 months BBSW rate to discount it. So you have to match the time horizon of your cash flow with the maturity of your discounting rate. Because you're discounting back 3 months, so you have to use 3 months BBSW rate to do that. And once you discount that, you will get that's $101 million for the floating rate bond. Now, for the fixed rate bond is just standard fixed rate bond valuation. So we were told the fixed bond rate is 8%. So 8% multiplied by 100 million divided by 2. So that's $4 million every 6 months, right? And when the next fixed rate payment will be made? In 3 months' time. All right, so yesterday a lot of people asked me why don't we discount the fixed rate coupon back 6 months? I mean, why should we? Because we're standing in this point, so that's 3 months away from today, right? You're going to exchange your fixed rate payment with your floating rate payment on the exact same day. So that's the whole idea of swap. So the first 4 million will be discounted back 3 months using the 3 months BBSW rate. And the next coupon, next fixed rate coupon will be paid in 9 months' time. So you're using the 9 months BBSW rate to discount that coupon payment back 9 months. And lastly, when you discount the last coupon payment, don't forget to discount your principal as well. And using the 15 months BBSW rate to discount back 15 months. And you get the value of your fixed rate bond is 104 million. Okay? Which means the fixed rate bond has higher value than the floating rate bond. Because you are paying the floating rate bond, right? Which means you pay less than, you receive more than what you pay, so it has a positive value to you. If you think taking a long position or short position is too confusing, just think about, if you're paying out less than what you receive, then of course it has a positive value to you. So that's how the valuation works. Does it make sense? Any question before we move on? No? All right. Another thing you have to know is designing a currency swap. Okay? So currency swap is also known as the fixed-to-fixed currency swap, which means it's kind of easier compared to the interest rate swap because you don't have to worry about the floating rate. all you're dealing with is exchanging the fixed rate with another fixed rate, but in different currencies, right? But I'll motivate why company enter into currency swap in the first place. So let's have a look at this situation here. It says Boeing, AAA rated aviation company needs to borrow 20 million Australian dollar to finance its aviation factory in Canberra in Australia. All right, so this is the typical situation how the currency swap was initiated. So we have a foreign company that would want to invest in Australia, which means he needs Australian dollar to build up the factory, right? And in the future, of course, the earning will be generated in Australian dollar as well. So just bear that in mind. And the second part says the Woodside Petroleum, a BBB rated company, is Australian company, is going to borrow $50 million to finance its shale gas exploration in Florida, United States. So we have an Australian company that's going to do exploration expedition in United States, which means this company, Woodside Petroleum, is going to incur US dollar denominated expense. And in the future, that shale gas exploration will generate US dollar denominated income. All right, so Boeing is a US company, and Bank of America is Boeing's long-term relationship bank. Okay, which means the Bank of America is able to offer Boeing the lowest possible US rate and the lowest possible Aussie dollar rate. Woodside Petroleum is an Australian company, and ANZ is Woodside Petroleum long-term relationship bank, which means ANZ is able to offer Woodside Petroleum the lowest possible rate in both US dollar and Aussie dollar. All right? And what we were told is the spot exchange rate is 0.5. Sorry, the US dollar versus AUD is 0.75. And what you were asked to do is you are asked to design a currency swap, and the swap would enable the swap bank, earn 20 basis point cuts, and also appear equally attractive to Boeing and Woodside Petroleum. So what constitutes the basis for the currency swap? Well, if you convert that 20 million AUD dollar using the spot rate, you would realize that that's equal to 50 million US dollar, right? Let me say this again. So if you're using the 20 million AUD using the spot exchange rate to convert that AUD, the 20 million Aussie dollar is precisely 15 million US dollar, which means they have identical notional principle, right? Both 15 million US dollar. So that constitutes a basis for a swap. So again, similarly, let's analyze their comparative advantage. Remember, Boeing has a better credit rating, so the Boeing would dominate in both US dollar denominated rate of borrowing as well as the Aussie dollar denominated rate of borrowing, right? So we see that Boeing enjoy lower cost of borrowing in both US dollar as well as the Aussie dollar. But the gap is smaller in the Aussie dollar for Woodside Petroleum, right? Because we see that Woodside Petroleum is able to access 8% Aussie dollar borrowing rate, and Boeing is able to access 7.6% Aussie dollar borrowing rate. So the difference is only 40 basis points. In other words, Woodside Petroleum has a comparative advantage in Aussie dollar. And it makes sense because Woodside Petroleum is an Australian company, and the ANZ would know Woodside Petroleum better, right? So that's why Woodside Petroleum has a comparative advantage in the Aussie dollar rate. All right, so you work out the difference. The difference is 1.6%. But we have to enable the Macquarie Bank to earn 20 basis point cut, so we're left with 1.4% to play around with. And we were asked to design a swap that will be equally attractive to both companies. So that's 70% basis points goes to two parties. So let's start with Boeing. So as the swap bank, we understand Boeing is going to build its aviation factory in Australia. So what Boeing really needs is Aussie dollar, right? But we also understand Boeing's comparative advantage lies in US dollar rate. So we're going to tell Boeing that, just for the time being, please borrow 15 million US dollar at a rate of 5%, US dollar rate. And because the aviation factories will generate Aussie dollar earning in the future, right? So Boeing can actually pay the swap bank Aussie dollar rate, because that's what Boeing really wants. Boeing wants to pay the Aussie dollar rate of expense. So Boeing can pay that. So Boeing can pay 8% Aussie dollar rate to the swap bank, then the swap bank passing the 8% Aussie dollar rate to Woodside Petroleum. Now we understand what Woodside Petroleum really wants is a US dollar loan. But because Woodside Petroleum has advantage in the Aussie dollar rate, so for the time being, the Woodside Petroleum is going to take out $20 million Aussie dollar loan and paying ANZ 8% Aussie dollar rate. Okay? So basically, Woodside Petroleum received 8% from Boeing and paying back ANZ 8%. So in and out, the Aussie dollar rate is cancelled out, right? Cancelled each other out. Now, how much Woodside Petroleum should pay the swap bank to enable him to be better off 70 basis points? Well, the lowest possible US dollar rate that Woodside Petroleum is able to get is 7%, right? So 7% minus 70 basis points, so that's 6.3%. So Woodside Petroleum would pay the swap bank 6.3% US dollar rate, and then the swap bank take 20 basis point cut, passing the remaining 6.1 back to Boeing, and Boeing would utilize the 6.1, would only utilize the 5% out of the 6.1 to repay his US dollar loan, which means Boeing made 1.1% gain in the US dollar rate, right? But Boeing is worse off 40 basis points in the Aussie dollar rate. So the overall gain for Boeing is also 70 basis points. Okay, so let me elaborate. So Boeing paid out 8%, received 6.1% from the Woodside Petroleum, then also pays the Bank of America 5%. So what Boeing is paying is 6.9%. But remember, 6.9% is 70 basis points lower than the lowest possible Aussie dollar rate the Boeing can ever get, which means Boeing is better off by 70 basis points. Now look at the Woodside Petroleum. Woodside Petroleum receives 8% from Boeing and paying 8% to ANZ, and also paying out 6.3% to the Boeing. So what Woodside Petroleum is really paying is 6.3%. But 6.3% is 70 basis points lower than the lowest possible US dollar rate that Woodside can ever get. So Woodside is better off by 70 basis points. Better off by 70 basis points. So the total gain is 1.4%. Does that make sense? So any question before we move on to the valuing the currency swap? Okay, so valuing currency swap is in fact easier than valuing interest rate swap, because we're valuing two fixed rate bonds, right? Two fixed rate paying bonds. Now, one thing you have to be aware of is the value of the swap is always denominated in US dollar, okay? So we're going to assume US dollar is our domestic currency, right? So let me say this again. When you're valuing the currency swap, always assume you are a US dollar investor, and US dollar is your domestic currency. So at the end of the day, you have to convert everything back to US dollar to calculate the value on the currency swap. Now, basically, if you are paying out the foreign currency, remember to convert the value of the foreign currency denominated bond using the spot rate, convert that back to the US dollar, right? So you are comparing the apple with apple, orange with orange. Does it make sense? So same thing here. So if you are paying the US dollar, so that's already paid out, so that's the minus sign in front of that. Remember to converting the foreign currency that you received in US dollar as well, using the spot rate. So the S0 is the spot exchange rate. Okay? Then the difference is the value of swap. So for example here, suppose that some time ago, Macquarie Bank has entered into a currency swap, which the bank received 5% per annum in yen and pays 8% in dollar once a year. So this is not semi-annual. So this is once per year. And the principals in two currencies are 10 million and 1,200 million yuan, and the swap will last for another 3 years. So the current exchange rate, so that's the spot rate, S0, is 110 yuan for $1. So you are given the 12-month LIBOR rate in Japan is, the LIBOR rate in Japan is for the 12 months, 24 months, and 36 months is following. And similarly, you are given the LIBOR rate, that's a typo, so just delete the 12 months. So the LIBOR rate in the US for the 12 months, 24 months, and the 36 months is following. And the question says, value this swap in US dollar. Okay, so basically you're valuing two fixed rate bonds in two different currencies. But then at the end of the day, you have to convert the Japanese yen's bond into a US dollar bond, then you compare the difference. Okay, so let's start with the dollar bond. So the dollar bond has a principal of 10 mil and paying 8% per annum, right? So that's 8% multiplied by 10 mil, so that's 0.8 paid every single year. And then you're using the US dollar LIBOR rate to discount each cash flow. So you're using the 1-year rate to discount the first year cash flow, using the 2-year rate to discount the second year cash flow, so on and so forth. And you work out the dollar denominated bond is 9.67 million. Now you do the same thing to the Japanese yuan bond. So the Japanese yuan bond is paying 5% coupon, so 5% multiplied by 1,200, so it's paying 60 million Japanese yen every single year. And bear in mind, you have to use the Japanese LIBOR rate to discount each coupon and also discounting the principal back to the present. So that's how much this Japanese yen bond is worth. And then remember to convert the Japanese yen bond into the US dollar. All right? And after converting, you realize your Japanese denominated bond is actually worth 11.02 million US dollar. So basically, you are paying the US dollar and receiving the Japanese yen. So you receive more than what you pay. So this currency swap has a positive value to this bank, which is 1.35 million US dollar. So the most important thing is value everything in US dollar. So any question before we move on? Valuing the currency swap. I think it's kind of easier compared to the valuing interest rate swap because you're just valuing two fixed rate paying bonds. That's it. All right, so let's get to the last example. So the last question says the cash price for 6 months, 1-year treasury bill, cash price for 6 months and a 1-year treasury bill are 94 and 89, respectively. And a 1.5-year bond that will pay coupon of US dollar, I think that's 4 million every 6 months, and currently selling for 94.84. And a 2-year bond will pay coupon 5 million every 6 months, and is currently selling for 97.12. So calculate 6 months, 1 year, and 1.5 year, and 2-year zero rate. So a lot of rate that we observe in the market is in fact not zero interest rate. So zero interest rate really measures the rate of return on this one-shot investment, all right? So you only invest X amount, then receive an ending value, and there is no intermediary payment in between. In other words, we cannot back out the 2-year zero rate from this 2-year bond. Why? Because this 2-year bond actually pays the coupon. So some of the return is realized in the form of coupon, right? Some of the return is realized in the form of intermediary payment. So what we can do is we can utilize other zero rate to back out this 2-year zero rate, similar to what we have done yesterday, right? So, but first of all, we need 6 months zero rate and a 1-year zero rate. Luckily, this 6 months treasury bill and 1-year treasury bill doesn't pay the coupon. So we can simply work out what is the rate of return on this 2 bond, then we use this known information to back out the 1.5-year rate, then we're going to use all that 3 information to back out the 2-year interest rate. So what does this 6 months treasury bill means? That means that you're going to receive the $100 face value at the end of your holding period. So that is, so that's what is the holding period return? So that's 6 divided by 94. So 94 is your initial value, 100 million is your ending value. So 6 million divided by 94 is your holding period return, but that return is only for 6 months, right? So you have to convert that into an annualized rate. So that's 2 multiplied by 6.383%. So that gives you the annualized rate. But remember, we have to do everything in continuously compounded rate. So we use the equation that we learned last week to convert this semi-annual rate into a continuously compounded rate. So that's 12.38% per annum. Does it make sense? Because that rate is only represents the return for 6 months, and after multiplied by 2, that's only the rate of return for every 6 months. Compounded semi-annually, right? So that's 12.7% per annum semi-annual compounding. Then we use the equation we learned last week to convert into a continuously compounded rate. And the same story goes to 12 months treasury bill. So the initial value is 89. The ending value is 100 million. So 11 divided by 89. So you'll get that much over the 12 months period. And then you convert that into the continuously compounded rate. All right? So these 2 rates represent the 6 months zero rate and the 12 months zero rate. Because they don't pay coupon in between, so they are clean. They are clean zero rate. Now, because this 1.5-year bond actually pays the coupon, so some of the return is realized in the form of coupon, right? So we can actually back out the 1.5-year zero rate. So what we can do is we're going to discount. So going back to this question here, because the coupon is $4 million every 6 months, right? So we can discount the first coupon using the 6 months zero rate. So where is this rate coming from? It's coming from the first step, right? So that's your 6 months zero rate. You're using the 6 months zero rate to discount the first coupon, and the 12 months zero rate to discount the second coupon. And lastly, we have this unknown information, which is 1.5-year zero rate. And we discount the principal plus the last coupon back 1.5 years. And we know how much it's selling for. It's selling for 94.84. So we have 1 unknown variable and 1 equation, and we can solve for that, right? So we can back out the 1.5 zero rate is 11.5%. Now we have the 6 month zero rate, 1 year zero rate, and a 1.5-year zero rate. Now we can actually back out this 2-year zero rate, right? Because we know how much this bond is selling for. It's selling for 97.12. So again, we discount each coupon using the corresponding discounting rate, which means you match the maturity of the discounting rate with the cash flow time horizon. And then lastly, we don't know what the 2-year zero rate is, so we set as unknown variable R. And we know how much it's selling for, so again, we can back out the 2-year zero rate is 11.3%. It's just tedious, but it's not difficult. So any question with the last one, determining the Treasury zero rates? All right, if no questions, so that's all. Thank you. Yeah, just give me 1 sec. Let me grab my stuff, then we can talk outside.